Okay, so for this basic exercise, what we're going to do is populate my string with first name and last name and a space in between, but we were going to enter everything one character at a time, okay? And then we'll have some control over how the data will be stored in this string. We've seen in the previous example, we couldn't store first name and last name in a simple character string like this one. Let me just go back here. Like my string 1, we were not able to store first name and last name because of the null character. Let's do that. Let's override that limitation. So let's go ahead and int I. We're just going to declare this for a for loop. We're going to do our for loop here. I equals 0, I less than 10. Now, as long as we're less than the array size, we're good. I plus plus. And we're going to do, this, scanf, %c, and percent my string I. And let's prove that's what got stored in there. So for example, printf the string contains %s/n my string. Now we're going to see what adjustments we may have to do to make sure we have a null character at the end of this whole string. Okay, so let's go ahead and run this for a minute. Compile and run. And let me see here. I forgot a semicolon here. As you can see, I get a prompt to enter something. So let's enter Bob Marley. And notice I was able to, right now on the keyboard, okay, to enter Bob Marley. And notice my scanf is waiting for our letters. If I hit enter, that will enter my /0 for me. That's the null character. Now watch what happens now. The string contains Bob Marley. Now let's make sure that indeed data got stored in the way that I wanted to. So one way to do this is we can go ahead and do a for loop again and inspect my string. So we could do something like this: for I equals 0, I less than 10 again, I plus plus, and let's go ahead and printf each character at a time. Okay, so %c space, and we're going to do and percent my string I. Remember, it's an array, so do it this way. Let me put a /n here, right here, to give me a new line. Now let's see how this behaves. Compile and run. And let's enter Bob Marley again. And we got a problem. What is it doing? It's printing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's probably right now printing my count. I don't want the n%. I see what it's doing. We don't want this n%. Okay, so we just my string I. There you go. All right, so let's compile and run. This is interesting. All right, so compile and run, and let's do Bob Marley again. There you go. All right, so now we're playing music here. So the space that was in there is right here, and then there was an additional space here. Okay. Now, what was interesting is that the addresses translated as C were numbers. That's something we will have to investigate why it did that. Now, if you wanted to know the addresses, then you would do something like this: %d And indeed, you could put %. That would give you the address where each character is stored. So let me just show you that for a minute. Compile and run. Okay. And so if you do something like this again, Bob Marley, now you get the addresses. Okay. So it looked like if you replace %D with a %C, you get the index. Okay, so let's go ahead and do that. That was fun. That was a fun discovery. So if you do this, compile and run. So you want to use that to your advantage in the future if you want to find the index of a particular letter. Okay, so this could be very useful. All right, very good. So we've learned an unintended lesson out of this through my mistake with the %C and the address. These as a combination produces an index. That was not my intent, by the way. But since we have that, you could use that to your advantage. This is what I had in mind, to show me exactly what was stored as a character at each memory location. So let's go ahead and compile and run again for my intended result. And let me just type it again, or let's put somebody else in there. James West. Here you go. So we're now in a Western movie. You could see it picks up the first name and last name without any problems. Okay. Had we not entered the data one character at a time and try to do James West like this. So let me just comment out this part here. And let's say we wanted to do it in this manner. Printf. Enter a name. Enter a full name. We've seen the limitation of doing this. Scanf. And that would be a %s. And that would be my string. And let's see what happens here. Compile and run. And if you type James West, okay, so you get your James, but you don't get the rest of it. Okay, and that's because of the null character that's in here already. Okay, so it didn't allow at runtime to populate the whole array for you. So one easy way to overcome this problem is to do it one character at a time. Notice you wouldn't even notice that that's what you're doing. Let's go ahead and rerun it again. Compile and run. Enter a full name. And Kelly Clarkson. And I ran out of space, and the reason is because I have more than 10 characters. Okay. All right, so now we see another limitation. So is there a way to dynamically allocate space for names that might be greater than 10? Well, you know, statically speaking, you can create an array that's much larger than 10. Or we're going to use some other techniques to create space or expand space based on how much data you need to actually handle. Okay? Which means you're going to have to allocate memory for more characters. At this stage, we're not doing anything at runtime where you're allocating memory, so you're going to run into limitations. Okay? As you can see here, again, we ran into the limitation here where we hit more than 10 characters, but we didn't lose the other characters even though we entered a blank here. Okay? So that's a big advancement there. All right, fantastic. I'll see you for the next lesson on how to handle strings again.